Hello everyone. In this video we are going to solve a cool polynomial equation. It's basically an algebra question. So let's look at how we can solve this question. We have s exponent 4 minus 4s squared plus 12 being equal to 9. So I'm going to use two methods in solving this, two very simple methods in solving this equation. So let's quickly get that. Now with the first method, so let me write here the first method. So with the first method, we have, let me write a question, 4s squared plus 12s being equal to 9. So what I'm going to do next is to just bring the 9 to the other side. So it's positive, it becomes negative, equal to 0. Now from here, what we can do is I can actually bring this on one side, and then also we can have this on the other side. So we have 4s squared, this becomes negative 12x, it becomes positive 9 being equal to 0, because when I multiply negative through, I'm going to get this back. Now I'm separating this from that because this basically gives me a quadratic equation which is very easy to solve. So let's solve this equation and then see how we can go about it. So in quadratic equation, you just multiply this with the exponent of the s squared, which gives us 36. 9 for 36. So since we have 36, we have to get values that when we multiply, we get 36. When we add these same values, we get negative 12. So basically you can see that we have negative 6 and then negative 6. So we're just going to replace that here. So we have negative 6s and negative 6s, and then we have positive 9 here being equal to 0. Now go ahead and then solve the quadratic equation. We bring 4 out, 4x out. We have s minus 3. We have 4 and 2, so we can just factorize 2 out, so that we have 2x here minus 3, and then we can also factorize 3 outside here. Then we have x here minus we have 2x minus 3 being equal to 0. So you can see that we have the same thing here. So from here we have s to the power 4 minus, so we have this, that being the same, and then the 1 outside. So we write the 1 outside, which is 2x minus 3, and then also we still have 2s minus 3, right? 2s minus to 0. But then what I can do next is we have s to the power 4. Since we have the same 2s minus 3 and they are multiplying, we can write this whole thing as the square of it, right, being equal to 0. So you can see that we have the square that, but then we have exponent 4 here, but then we can also write s exponent 4 as s squared and then 2 out exponent 2. So we can have just 2s minus 3 exponent 2 being equal to 0. You realize that they all have exponent 2 on both sides. So I'm going to leave this one here and send this to the other side. We have 2s minus 3 exponent 2 in this case. So to get rid of the exponent, why don't I apply square root or root on both sides? So let's go ahead and apply square root on both sides. Now applying square root of both sides, we have s squared here, and then we apply square root here also. So this gets rid of that, and then from here we have this getting rid of this in this case. So we just have s squared being equal to 2s minus 3. We have s squared in this case, bringing this to the other side, 2s minus 3. But then remember, since we apply the square root on both sides, what we are getting here is that we can get positive and negative on both sides. So we have positive and negative values on both sides, so positive and negative. So we have the positive part and then also the negative part. So let's take the positive part. So with the positive part, we have this, so the whole thing here being equal to 2s minus 3, and then with the negative part we have s being equal to negative 2 minus 3 here, right? So let's solve both parts and see what we are going to get. So with this part we have s squared minus 2s plus 3 being equal to 0. Remember, in this situation we still have a quadratic equation. Now we can solve this, we can't solve it straightly because it's going to give us some imaginary, so we can solve this using the general formula. So we have the quadratic formula. So in this case, a here is equal to 1, the coefficient of a is equal to 1, coefficient of b is equal to -2, and coefficient of c here is equal to 3. So we can just use this formula, s being equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a. Now when we do the whole of that, we are just going to get, so in this case b here is -2, so -2 gives us positive, and then we have plus or minus the square root of b squared, which is -2 exponent 2, which gives us 4 minus 4 multiplied by 1 multiplied by 3, it gives us 12, divided by 2a, which is 2 multiplied by 1, which is basically 2. So s is just going to be 2 plus or minus the square root of 4 minus 12 here is just going to give us minus 8 in this case, divided by 2. So in this case, to get rid of the negative, we have this being 8 and then multiplied by -1, right? But then we know that -1 is equal to root of -1 is equal to what? Imaginary. So in this case, we can just replace that. So we have x being equal to this is just going to, so let's continue over here, continue the whole thing over here. So we are just going to get this to be x being equal to 2 plus or minus the square root of 8 here, 4 times 2, and then we can have the imaginary outside, replacing the square root of -1 equal to I. So we place it there, equal to 2. S is basically going to plus or minus square root of 4 is 2, bring it outside 2, that's divided by 2, and just dividing all side by 2, we just have this to be 1 plus or minus the square root of 2i in this case. So that would be the possible values of s for the positive side. Now let's look at it on the negative side. Now with the negative side, we have this to be s squared. So let's bring in everything, it becomes negative, so sending it becomes positive 2s, and this also becomes positive 3 equal to 0. Remember, the possible value is 3 and 1, so we have s squared plus 3s plus s plus 3 equal to 0. So in this case, we have this to be s outside, s plus 3, and then we just have s plus 3 also here being equal to 0. So from here we have s plus 1 here, and then we have s plus 3 here, right, being equal to 0. So therefore we have s plus 1 equal to 0, s equal to -1, and then also s plus 3 equal to 0, and then s becomes -3. So in this, therefore s equal to -1 and -3. So with the first part in all, we can then go ahead and conclude that s equal to -1, -3, and so it has real solution and also complex solution, 1 plus this and then imaginary. So we have these values being the possible values of s in this case. So this is basically the first method. I'm going to go through the second method. So we have a second method. Now with the second method, what we are going to do is that we are going to write the general equation, which is 4s minus 4s squared plus 12x minus 9 being equal to 0. We are going to write it as a product of two quadratics, right? Writing this as a product of two quadratics, and then the identity I normally use is that, now looking at this equation over here, writing this as a product of two quadratics, we have s squared plus as plus 3, and then also s squared minus as minus 3. Now I'm choosing minus plus or minus 3 here because we have -9 here, so we can have positive 3 multiplying -3, we have -9. Now I chose ax, positive as, negative as, because we are going to have both the positive side and then also the negative side also. And one thing is that they are also going to terminate the s cube, because in the equation there's nothing like s cube that I've written over here. It only works when there is no s cube, and in this case there's no s cube, so this quadratics that I've written over here works. We have positive 3, negative 3 catering for this, and then distribute what we have over here. So we have s squared plus as plus 3, and then s squared minus as minus 3. Now this is a general one you can use in solving any polynomial equation, but then you just have to remember, if the polynomial equation does not have s cube in it, if it does not have s cube, you can use this, just changing the last part, which is the coefficient over here, the c over here. So you can see that it is negative 9, just bring a positive 3 and a negative 3, right? So this will work. All right, so from here let's go ahead and distribute. Now distributing, this is going to multiply everything. As will also multiply everything. 3 also multiplies everything. So in the first case we have s to the power 4. Over here we have negative a s cube. The next one is negative s squared. The next one is a s squared. Then as cube, and then we have negative a squared s squared. Now the next one is negative ax squared, negative 3ax, and then 3 multiplies that, positive 3s squared. We have negative 3ax, and the next one is this negative 9. Now this is what we're going to have. Now from here we can just look at the like term. So we have negative s squared, we have positive s squared, which goes away. This is also going to go away. We have negative as cube, we have positive as cube, which also goes away. And then from there we have what is remaining is just s to the power 4, and then the next one is just negative a squared s squared. We have negative as, negative ax, so it becomes negative 6 ax, and we have negative 9 here. So that will be the that will be what we have after we distribute. So from we have this, what we are going to do is that we are going to equal this to the general equation. We have s to the power 4, and then negative so that one is s to the power 4, negative 4s squared, negative plus 12s, sorry, and then we have negative 9 being equal to 0. So we equate this one also equal to 0. Now comparing what we have, the identity here, to that of the general equation, realize that s squared, we have s to the power 4, s to the power 4, we have negative as squared multiplied by s squared. So you can see the relation here, so we can compare this to that. Now comparing this to that, we have negative as a squared s squared being equal to negative 4s squared. Negative gets rid of negative, s squared gets rid of s squared. We have a squared being equal to 4, and then from here we can just have our a here, just applying square root to both sides. So when I put square root here and then the square root here, this gets rid of that, and then we have a to be plus or minus 2. So we can have a to be positive 2 and then negative 2 in this case. Now if we look at the second part, which is the second part of the identity, by comparing this to that, negative 9 to that already is already there, so we can also compare this to that. So we have that one to be negative 6 ax minus negative 6 as being equal to positive 12x, right? So in this case we have x getting rid of x in this case, and then we have this to be negative 6a being equal to 12. Divide both sides by negative 6, and then a here is just equal to negative 2 in this case. So we realize that therefore a is equal to plus or minus 2, and then we also have negative 2, plus or minus 2 from the first part, and then the second part being negative 2. So you realize that we have negative 2 on both sides. So from here you realize that a should be equal to positive 2. Now the first part we have a to be equal to 2, So the second part, a to be equal to 2, and the first part, a to be equal to plus or minus 2. So the second part gives us a confirmation that therefore a should actually be equal to negative 2 and not positive 2. Now, what do we do next? Now we are going to take the formula again and then substitute the value of a into the formula. Now let's do that. So realize that we wrote this as s squared plus, that is the identity, plus 3, and then we have s squared minus as minus 3, right, being equal to 0. Now with this identity, we are just going to substitute this into it. So we have a equal to negative 2 now becomes s squared. So when I substitute a equal to negative 2, I have negative 2x plus 3 here, and then over here we are just going to have s squared, because negative and there is negative here, become positive 2ax minus 3 being equal to 0. So the first part becomes s squared. So from here, what we are going to do is now go ahead and distribute, but even before we, so this becomes just 2s. Even before we distribute, we can just take one of the formula and then equate it to a certain variable. So let's take the first one. We are taking this being equal to 0. So we have s squared minus 2x plus 3 being equal to 0. Now if you look at the identity, comparing it to the first identity that we had, you realize that we add that one to be, that is the s squared minus 2x here. In this case, we add that one to be so it's here. So comparing this to the first one that we had over here, as you can see, s squared minus 2s plus 3, we have it over here. We have the value of s to be plus 1 plus or minus the square root of 2i, right, imaginary. That's what we had. Now, so that's basically for this one. Now let's look at the second part here. S squared plus 2s minus 3 being equal to 0, and you realize that just solving this, we are going to get this to be negative s plus 3x here minus 3 being equal to 0, and then we have s minus 1 here plus 3 s minus 1 here being equal to 0, and therefore s minus 1 equal to 0, s will be equal to 1, and then we have the one outside, s plus 3 being equal to 0, s will be equal to negative 3. So therefore s equal to 1 minus 3, and then 1 plus or minus the square root of 2 and imaginary, just as we had in the first method that we use. So whatever method you use, you should get the same answer. Thank you very much for watching this video, and I'll see you in the next video.